Hi guys, my name is Stanley and welcome back to my channel. And today we're talking about Newton's 3 laws. So since this is my first science video, I'm going to explain the objective of these videos. So my goal is to make hard, long, or complicated science theories and laws and turn them into short videos that are easy to comprehend. So I think that we should start with Newton's 3 laws, since it is a basic thing you need to understand before you can dive deeper. Okay, so Newton's first law is also called the law of inertia. It states that an object at rest stays at rest, and that object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Now, that might sound super hard and complicated at first, but it's actually quite easy to understand. For people that don't get that, it basically means that an object will not move unless you push it, or roll it off a table, and the object moving will keep moving until you stop it with your hand, or the friction or air resistance stops it. So if you leave a ball on the table, it won't move. So here's some mathematical parts. If an object is moving at 5 meters per second, it will stay moving at that speed. If an object is moving at 0 meters per second, it's probably going to stay there unless there's an external force, which is currently considering all these stuff in a perfect environment where there are no external forces, no wind, no gravity, none of that. Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and it's inversely proportional to the mass of the object. Now, this one's super hard and complicated, but you can easily summarize it to F net equals mass times acceleration. F net is the force in newtons. Mass is being how many atoms is in the area, not the weight. But we use mass as on Earth gravity for these calculations. The acceleration is meters or feet per second squared. For example, if you have an object with a mass of 10 grams and the acceleration is 10 meters per second squared, then your force is 0.1 newtons. Now, you're probably going to say, Stanley, there's gravity. Did you forget gravity, air resistance? But remember, we're still in a perfect environment. Later on, as you go deeper into physics calculations, you will learn of introducing 9.8 meters per second squared, the gravity force on an object when it's in the air, or it's always pulling down. You can learn the drag coefficients and all that kind of stuff of air. But that comes later. Newton's third law states that for every action, there is an equal and opposite reaction. In simple English, if I have an object like this pillow, if I push on it up, it's going to go up. If I leave on it, since there's gravity, it'll go down. So basically, try this. Sit in a chair that can roll like an office chair. Throw something heavy like that pillow over there, super fast in one direction. If your feet are off the table and your chair can roll fast enough and you threw the object fast enough, you should move a little backwards. Rockets work the same way, because the gases are expelled at super high speeds out the back of the rocket. Then the rocket will move forwards. That's how rockets work in space. Not because they're pushing off the launch pad or pushing off the air, but because they're throwing objects rapidly out. But people want to say, if this law is correct, then if you push down on the ground vertically, the Earth should move down. Well, that is correct, but the Earth's mass compared to yours means that the Earth will move fractions compared to you do, so that's why you go up. Thank you for watching this video. If you like this video, subscribe, like, and share. Remember to comment down what theories I should cover in the next video, and bye!